Welcome to Sanjana's Education Strategies. Learn the trade secrets to cover vast concepts in no time. If you like the video, please do like, share, and subscribe.
Okay, acids are having sour taste and bases they are having soapy touch and bitter taste. Their taste is bitter in taste. So acids we cannot touch, so we cannot feel how it is. Some acids they are corrosive in nature which causes some skin burns. Okay, next is about bases. Bases, all bases contains O minus, that is a metallic oxide, or OH minus, that is metallic hydroxide as its constituent element. Okay, so when you take any compound, that compound if it is containing oxide or metallic hydroxide, then you can say it is a base. For example, okay, you can see, for example, CuO, copper oxide, so it is having oxide, so it is a base. NaOH, sodium hydroxide, it is having hydroxide OH, so it is a base. Then ammonium hydroxide, okay, so it is having OH, so it is a base. Okay, so any compound which is having O minus or OH minus, O2 minus, the valency of oxygen is 2, so O2 minus or OH minus. Next is about salt. Salt is when you are replacing H plus ion in acid by metallic ion or ammonium ion. It is known as salt. That is acid plus base, it gives salt plus water. Okay, this is a reaction. Acid plus base, it gives salt plus water. Okay, that's all about acids. Now, we'll see in detail about acids, and before that you should know some examples of acid. So, this is a base, NaOH, because it is having hydroxide. So, NaOH plus HCl, which is acid, it gives NaCl, which is salt. See, it is replacing, you can see H plus, it is replaced by a metallic ion. So you got NaCl. Okay, H plus is replaced by a metallic ion. So you got NaCl plus H2O. CuO plus H2SO4 gives CuSO4 plus H2O. NH4OH plus HCl gives NH4Cl plus H2O. Ammonium hydroxide, it combines with HCl and gives ammonium chloride plus water. Then CuO, copper oxide plus HCl, hydrochloric acid, it gives copper chloride plus H2O. Aluminium hydroxide plus nitric acid gives aluminium nitrate plus water. Then sodium hydroxide plus nitric acid, it gives sodium nitrate plus water. Okay, these are some examples for base plus acid plus base reaction, that is neutralization reaction, which forms salt and water. Okay, now we'll see about acid in detail. So you just see this. First, I told you already, acids they are having sour taste. Okay, they are having a sour taste. So you can see in this acid, the Latin word of acid is acidus, which means sour taste. It means sour in taste. Okay, acidus. And what is said to be an acid means a compound which contains one or more hydrogen atoms, and when that compound is dissolved in water, it produces H3O plus, that is hydronium ions. Okay, a compound which is having hydrogen atom, which is having one or more hydrogen atom, and when we are dissolving it in water, that compound produces hydronium ion. So you can see an example, HCl. It is a compound which is having hydrogen, which is having one or more hydrogen. So here it is having one hydrogen. Yes? Okay. So it is an acid. So when we are adding this HCl in water, what it is producing? H plus plus Cl minus. It dissociates. So first process is dissociation. Okay, it dissociates into ion. Which dissociates? HCl dissociates into H plus and Cl minus ions. Now this H plus is not stable. It combines with H2O again. Okay, it cannot be present independently. So it again combines with H2O to form H3O plus. Or you can write it as OH3 plus, because this plus sign is for this hydrogen. Okay, not for this oxygen. It is for hydrogen. Okay, so we are writing it as H3O plus. It forms hydronium ion. Hydronium ion. There are several other examples. So you can see these examples. H2SO4 plus H2O, that is sulfuric acid, plus water. It gives 2 hydronium ions. Why? Because 2 hydrogen is present. Okay. So it gives 2 replaceable hydrogen is present. That is to be noted. Okay. Always replaceable hydrogen. How many replaceable hydrogen are present? Only those many hydrogens will be replaced by water. Okay, so it forms 2 hydronium ions and sulfate ion. Again, phosphoric acid. Okay, phosphoric acid, it is having 3 hydrogen. So it forms 3 hydronium ions, 3 replaceable hydrogen. So it forms 3 hydronium ions and phosphate ion is produced. Again, CH3COOH. Here, totally we are having 4 hydrogen. Okay, but there is only 1 replaceable hydrogen, so it forms only 1 hydronium ion and CH3COO minus. Okay, so here the main concept is this H plus, that is 1 proton. You can call it as proton because H plus is proton. So proton plus water, it gives hydronium ion. Hydronium ion. So this reaction in short way we can write it in one step. The actual process is like this. First it dissociates, dissociation takes place, so it forms H plus and Cl minus. Later only that H plus again combines with water to form hydronium ion. Okay, that is about this process. Next we will see about some reactions in acids. So this you have to be thorough. So this is a small trick to learn the reactions. So if you are thorough with these reactions, then no matter, you can write it easily. So first hydrogen plus a non-metal, it gives acid. Then acidic oxide plus water, it gives acid. A non-metal plus acid, it gives acid plus water plus oxide will be formed. Salt plus a less volatile acid. That means an acid which can vaporize easily. Okay, it forms salt plus more volatile acid. So this is in presence of heat. Okay, now based on this we will just write the equation. We'll see the example for each sum. Okay, now see nice carefully. First one is hydrogen plus non-metal, it is giving acid. Okay, so H2 plus, we are writing any non-metal, I am using chlorine. Okay, so it gives an acid. HCl will be formed 2. Same way, if I write H2 plus sulfur, it is a non-metal. So it gives H2S. Okay, this is an example for first one. Hydrogen plus a non-metal, it gives a acid. Now second one you see acidic oxide plus water, it is giving a acid. Acidic oxide plus water. So I am taking one acidic oxide, SO3. Why I am telling this as acidic oxide? Because it forms sulfurous acid. Okay, it forms sulfurous acid. Sorry, it forms sulfuric acid. SO2, it forms sulfurous acid. Okay, so SO3, it forms sulfuric acid. So I am telling this as a acidic oxide. Acidic oxide plus water, it is giving acid. What acid it is giving? Sulfuric acid. Yes. Again, sulfur dioxide plus H2O, it is giving sulfurous oxide. So H2SO3. Okay, that is second one. Okay, same way we can write for various examples, like you can see this. Non-metal plus acid, it gives acid plus water plus oxide. So a non-metal, I am writing a non-metal, sulfur. Okay, sulfur plus acid, I am writing HNO3 acid, it gives acid plus water plus oxide. So first it forms acid. So from this you can write what acid. Sulfur is there, so it forms sulfuric acid, H2SO4, plus it is forming water and it is forming oxide. What oxide? Since it is nitric acid, it is forming nitrogen dioxide. Okay, now I am taking another one element. If I am taking phosphorus, it is a non-metal. If I am combining it with HNO3, it forms phosphoric acid, H3PO4, plus water, plus since it is nitric acid, it forms nitrogen dioxide. Okay, yes. Okay, next is salt plus a less volatile acid which cannot vaporize easily. On heating, it forms salt plus more volatile acid. So salt, first you're writing any salt, I'm writing NaCl plus less volatile acid. H2SO4 is less volatile acid. On heating, it forms a salt, NaHSO4, okay, plus a less volatile acid, that is HCl is formed. Okay, this is very important, so please learn. Okay, that's it about reactions. So if you're thorough with this table, if you're thorough with this chart, then it is very easy for you to learn. Okay, next after this we'll be seeing about some physical properties of acid. So first of all, you know already that acids are sour taste. Then some acids, they are solid, some they are liquid in room temperature. Okay, some are solid and some are liquid in room temperature. Then you should know that mineral acids have corrosive action on skin. Yes, so you have to understand first about the two categories of acids. So that I will take first. So there are two types of acids, that is there are different classifications of acids. So based on the carbon presence, there are two types. One is organic acids and another one is inorganic acids. Organic acids, they contain carbon along with hydrogen, and inorganic acids, they do not contain carbon, but there is an exception. Carbonic acid, it contains carbon along with hydrogen, but this is a mineral acid. I mean, this is a inorganic acid. Another name for inorganic acid is mineral acid. Okay, so this is an exceptional case, but this is a weak mineral acid. Okay, since it contains carbon, it is a weak mineral acid. Usually inorganic acids are strong, but carbonic acid is the only inorganic acid which is weak. Okay, which is weak, and also it is non-corrosive. Usually mineral acids are corrosive, they cause skin burns, everything, but this carbonic acid is non-corrosive, and they are also used in many soft drinks like Coca-Cola, etc. So daily beverages, it is used. Okay, so organic acids, they are present in plants. Inorganic acids, they are mainly present in minerals. Okay, that's it about organic and inorganic acid. Next is a simple calculation which you have to understand. You see HNO3, nitric acid, okay, HNO3, it is having oxygen along with hydrogen. Okay, so it is known as oxy acid. So if any acid contain oxygen along with hydrogen, it is known as oxy acid. Then you can see here it contains hydrogen with a non-metal. If there is hydrogen with a non-metal, you call it as hydracids. Okay, you call it as hydracids. Next, about the classification depending on the basicity. depending on the basic nature of acids, it is divided into three types. One is monobasic acid, dibasic acid and tribasic acid. So first of all, you should understand what is this basicity. So the basicity of an acid is defined as the number of hydronium ions that can be produced by the ionization of one molecule of that acid in aqueous solution. So the number of hydronium ions it is produced when a particular acid, if it is ionized in water, how many hydronium ion it is producing. Okay, that is basicity. Okay, now we'll see about three types of acids based on basicity. First is monobasic acid. Monobasic acid, acids which on ionization in water, if it is producing one hydronium ion, then you can call it as monobasic acid. So you can just see the examples. So HCl plus H2O, it gives one hydronium ion plus Cl minus. Again HBr plus H2O, see what I have underlined, it is acid. Okay, so HBr plus H2O, it gives H3O plus Br minus. These are hydronium ions. Okay, HNO3 nitric acid plus water, it gives one hydronium ion plus NO3 minus. CH3COOH plus H2O gives H3O plus CH3COO minus. Okay, now these acids, when we are adding to a base, monobasic acid, when we are adding to a base like sodium hydroxide, if we are adding to a base, it forms only one normal salt. Why? It is producing only one hydronium ion, so they have capacity to produce only one normal salt. NaCl, one normal salt will be produced. This is about monobasic acid. Now here is an exceptional case, CH3COOH. Okay, CH3COOH, it is having 5, I told you already, it is having 5 hydrogen, but only one replaceable hydrogen is present. So it produces only one hydronium ion. Okay, it is an exceptional case. Next is about dibasic acid. Now dibasic acid, from that name you can understand the acids on ionization in water which produce 2 hydronium ions. So in the first step it is producing one hydronium ion, then again in the second step it is producing another one hydronium ion. So totally it is producing 2 hydronium ions. Okay, that is known as dibasic acid. So carbonic acid is also an example. Carbonic acid plus H2O, it gives 2H3O plus carbonate ion. Next, H2SO4. Okay, so H2SO4, that is sulfuric acid, plus NaOH, it is a base. I am taking a dibasic acid plus base. It gives one acidic salt, another one normal salt. One acidic salt and normal salt. So you can easily remember dibasic acid, so 2, which means it forms one acidic salt and another one basic salt. Sorry, normal salt. One acidic salt and normal salt. Okay. Next is about tribasic acid. So in tribasic acid, acids which on ionization, when it produces 3 hydronium ions. Okay, so you can see example H3PO4, that is phosphoric acid, plus water, it is forming one hydronium ion. Again with water it is forming another one. Again with water it is forming another one hydronium ion. So totally now 3 hydronium ions are formed. Okay, same thing is applicable for citric acid also. Okay, citric acid. So I'll just write the formula. Citric acid, it is C3H5OCOOH thrice. Here you have to understand totally 8 hydrogen is present. Totally 8 hydrogen is present, but only 3 is replaceable. Other 5 is not replaceable. So only this 3 produces 3 hydronium ions. Okay. Yes. Now phosphoric acid, if we are adding it to a base, if we are adding a tribasic acid to a base, it forms 2 acidic salt, 1, 2. Okay, 2 acidic salt and 1 normal salt. From its name you can take tribasic now, which means 3. So it forms 2 acidic salt and 1 normal salt. So if you have any doubts based on today's topic, you can just ask me in your comments, and please do like, share and subscribe. For more videos, please do subscribe my channel, and thank you so much.